So let's say we were to find the equation of the line with slope 2/3 that goes through 4/7. Find the equation of the line with slope 2/3 that goes through the point 4 and 7. So basically, like I said, we know something about the graph. Can we go back and get the equation? Well, different ways of doing it. If you like another way, that's fine too. But anytime I see find the equation of a line, unless it's a special horizontal or vertical line or something like that, here's what I say. If it says find the equation of a line, I'm thinking y equals mx plus b. We'll stick with that. I want a y equals mx plus b. Okay? Now, the thing of it is, to do that, to get that equation, I need to know two things. I need to know the m, and I need to know the b. Now, it just so happens in this case, I'm in good shape, at least half of it anyway, right? Which of these do I have of m and b? I have m, don't I? I have the slope. That's m. M is the slope. I've got the m already supplied for me. M is 2/3. So let's write that in. That leaves only one thing to do left, and that is to get the b. And this is how I do that. I don't have b supplied here. However, I do have this 4/7, which is an x comma a y. Neither one of those is b, but I can say that's an x and a y, can I? And so I can plug those in for x and y here. X is 4, y is 7. And what that does is that sets me up where I can find out what b is. If I can solve this little bit here. First of all, I'm multiplying fractions there. 2/3 times 4. Well, that's 4 over 1. And multiplying fractions, you multiply across, don't you? So you've got 2 times 4 is 8. 3 times 1 is 3. So that's 8/3. And so to solve for b, all I have to do is subtract the 8/3, right? And so I'm going to have 7 minus 8/3 equals b. And however you want there to get b, looking at it, again, 8/3 is 2 2/3. So 7 minus 2 2/3. One way we could look at this, is that 4 1/3? So I could say b is 4 1/3. Usually the book will use improper fractions. 4 1/3 is what improper fraction? 13/3, yes. 4 times 2 is 12, plus 1 gives me 13, so it'll be 13/3 is my b. So now if I just plug that back in to this, that's my equation. Y equals, so I've got the m is 2/3, and now I know the b is 13/3 or 4 1/3. I wouldn't count it wrong if you did that, but that's your equation right there. Okay on that? Like I said, if you like point slope, feel free, do that. But this is the way I like to show it anyway. Okay? All right, well, what if I had this? What if I had to find the equation of the line that goes through two 9 and 4 3? Okay, so again the goal is y equals mx plus b. That's what I want to find. right? Find the equation of a line, and that's usually what I want, y equals mx plus b. However, I have a slight problem here because do I know m? No. Do I know b, or is it given in the equation? No. Neither one of these gives me the m, and neither one of those gives me the b, the y-intercept. However, what can I do to remedy that? Yeah, I do have 2 points, and so through 2 points, if I first of all, so I'm first going to here use the slope formula that we talked about a moment ago. The m equals, it's y2 minus y1 over x2 minus x1. Since I've got 2 points, first x, first y, second x, second y, I can use this, and that'll find my m. All right, so let's see what that is. Let's take the second y, which is 3, minus the first y, which is 9, and then divide that by the second x, which is 4, minus the first x, which is 2. That gets me negative 6 over 2, doesn't it? Which is, nicely, negative 3. All right, so that gives me, now we can go to y equals mx plus b, because that gives me the m, doesn't it? Now I know, got half of it done, found. I know it's y equals negative 3x plus b. All I need to now know is b. How do I get it? Substitute an x and a y. I've got a choice here. It doesn't matter which one. I can use this for x and y or that for x and y. It doesn't matter. But let's choose this one. Let's plug in x to be 2, y to be 9. Yeah, that'll get me a way to find b there, doesn't it? So that's 9 equals negative 6 plus b. All I have to do is add the 6. And that's telling me 15 equals b. So what's my equation? Y equals mx plus b would be y equals, I found m to be negative 3. So it would be negative 3x. The b I found to be 15, so it's negative 3x plus 15. Right there you go. Okay? All right. Let's do one more of those, just to mention one little thing here. This one's got some decimals. All right, so find the equation of the line through 4.2, comma, negative 3.5, and 5.0, negative 6.4. Same basic problem, but with decimals and some negatives. See what we go there. All right, so again, we want y equals mx plus b, but we're going to have to start with the slope formula first. y2 minus y1 over x2 minus x1. Difference of the y's over difference of the x's first. What does that get me? Second y is negative 6.4 minus the first y, which is negative 3.5. Then the second x is 5.0 minus the first x is 4.2. What does that wind up being? Well, on the top I do have the negative minus thing, so that's positive 3.5. So it's negative 6.4 plus 3.5. What's that? 2.9 negative. And then the bottom is 0.8. Now, the reason for mentioning this, actually the next one we do will have some decimals in it, and I wanted to mention, usually what we're talking about here is some data points. And so if I'm going off of data points, this one, let's do this with, it is a negative divided by positive, so that is a negative. But since the data comes in decimal, one decimal place, let's do our rounding here. Let's round the slope here to a decimal, 1 decimal place. What is negative 2.9 divided by 0.8 if you punch that in? Somebody? 3.6 rounded? Okay. So it'll be 3.625. So yeah, let's round it off to 1 decimal place, make it 3.6, negative 3.6. We can do that for these decimals like this, okay? All right, so now we know y equals mx plus b. This is where we want to go. We've got the m is negative 3.6. So it's negative 3.6x plus b. Now all I have to do is plug in an x and a y, find the b. Got it my choice. It doesn't matter again. Either one's going to give you the same one. Let's make the x 4.2 and the y negative 3.5. So that'd be negative 3.5 equals, let's go over here. So it'd be negative 3.5 equals, what's negative 3.6 times 4.2? Negative 15.12 plus b. So add the 15.12 and we got our b. Is that 11.62? Is that right? 11.62 is b. So let's just round that off to 11.6. Do 1 decimal place for both. Okay, so that's y. Equation-wise would be y equals negative 3.6x. Since m is negative 3.6 plus 11.6 is my b. All right? With me on that. All right, so let's finish off with today. Little problem here. Kind of an application, I guess you might say. Do this little handout here. Everybody get one? All right, so we've got years 2005 through 2007. Bunch of points, okay? Yeah, this should remind you there of scatter plots. So that's going to be where we start. All right, so on the handout, we've got the years 2005 through 2011. This is enrollment at Lincoln University, wherever that is. And so number one problem is scatter plot. That's what we did last time, right? Did a little bit of scatter plotting. So I want to draw out a nice little scatter plot for this data. All right, so my year, let's go along the bottom here, and then the enrollment will go on the y-axis here. So again, however you want to, I can mark it off 2005, 2006, but in a moment I will change this up anyway. So let me just say this is 5, 6, 7. Let me go ahead and make the transition here. 10 and then 11. So 5 is going to go to year 2005. Something like that. Then my enrollments, well, it's 1475 to 1720, so I need to mark off maybe in increments of 50s. Start at 1400 or 1450, something like that. Then 1500, 1550, 1600, 1650, 1700, and then 1750, something like that. Okay? And so I've got 2005, 1475, 2006, hey, that's nice, right at 1500, 2007, 1510, 2008 is 1560, so that would be right about in here. 2009 is 1640, so it's close to that one. And then 2010 is 1690, right there. And then 2011 is 1720. Okay. All right. So that's what we did a little bit of last time. However, number 2 is we're to draw a line of best fit. We haven't done that one yet. Yeah. Instead of just connecting the dots here, as you can see, if we connected the dots, it'd be kind of a jagged little line there. But what I want to do is eyeball in here, so to speak, what's called a line of best fit. By that, what I mean, I want to draw a line, a straight line, that pretty well represents the data here as best I can. Now, what I want to do is kind of draw a line that goes kind of in the middle. And I'm going to use two of the points. If I use, on mine anyway, yours may look slightly different. If I use, say I use 6 and 7 here points, if I drew that line in, that's not a very good line that centers it up, is it? Because it goes way off up here. It's way off the line up here. So line of best fit, you just want it kind of go a line down the middle. Best way to describe it. With all points. As best you can. A line down the middle of all the points. And whatever 2 points accomplishes, you may choose 2 different ones that works just as well. This is kind of an approximation here. But I'm thinking maybe just looking at these, the goal basically is to have more as many points on the above the line as below the line. So I'm thinking here, and yours, like I said, you may have selected 2 different ones already, but I'm thinking 6 and 9 points. Kind of does that on mine anyway. Okay, because that puts these 2, these 3 above, and those 2 below. So I did 0.6 and the one at the 9 also. That's the one I used. Like I said, it doesn't have to be those 2, but by my graph here, those 2 look to be pretty good. Okay? All right, so that's line of best fit. So number 3 is then finishing off using t equals 0 as 2,000, which that's what I did. And I'm using t here instead of x. Find a linear model of the data based on this line of best fit. Well, linear model, that's synonymous with linear equation. So I want to find a linear equation for this data. What does a linear equation look like? Well, that's what we just talked about. Y equals mx plus b is usually the format you want. Now in this case, I am saying t instead of x, so the linear model is going to be y equals mt plus b. That's what I'm looking for. I'm looking for a line So I'm looking for this y equals mx plus b, which in this case I'm using t instead of x. T for time instead of x. Okay? That's what I'm looking for. Now, how do I get such a thing out of, well, that's where these points come in. I use, in my case, I used the 6 and the 9 points, which the 6 is 1,500. And the 9 was, what, 1640? So let's put it in point form there. Now, doesn't this look just like we were just doing? Find a linear equation off of these 2 points. Isn't that what we just did? We just did that. All right, so how do we do that? Get rid of this. So we're done with that. Well, first of all, I need to know 2 things. I need to know the m, and I need to know the b. To find the m, right, it's going to be the difference of the y's over difference of the x's, or t's in this case. Yeah, use the slope formula. Take the difference of the y's, 1640 minus 1,500. Divide that by the difference of the t's in this case, but subtract the y's, subtract the t's. 140 over 3, which is a pretty good fraction, but again, since this is data, let's round it off to a decimal place here. What is that? Huh? 46.6 repeating. So let's say 46.7. Slope is 46.7. Okay, so now I know my m is 46.7. So I know it's y equals 46.7 t plus b. Now all I need to do is figure out the b. Now just plug in a t and a y, right? Plug in one of these for t, one of those for y. I'll just use 6 and 1,500. Just plug in the t to be 6, the y to be 1,500. And that should find out for me the b. Is it 233.5? Did I do that right? 46.7 times 5? 233.5? That sound okay? Does that sound all right? Somebody check me on that? So I don't get it wrong. Okay, thank you. All right, so then you subtract the 233.5. And I'm seeing that's going to be where to get the 5? I don't know. Thank you. That's why you're looking at me funny. All right. This should be 6, yes. I don't know where I got 5. I just made that up. All right, so 6. Just checking, y'all. Every once in a while I'll check to see if you're still awake back there. Yeah, I missed that one. 280.2. Everybody change that. That should be a 6, so this should be 280.2. Now subtract 280.2, and that'll be what b is. 1,500 minus 280.2. How much? 1219.8. So the equation, the linear model is, well, we got the m is 46.7. T plus b is, we've got 1219.8. How about that? All right, now there is a number 4 to this one on the back. Before I forget, just about to, I forget. So yeah, once we have the linear model, then we can use it to predict here, using the model, predict the enrollment in 2015. Well, if we're going to 2015, that's a time in years, and 2015 would be which year? I think it was 2000 was 0, so that would be t equals 15. Yeah, so now we know t is 15, so just plug that in. 46.7 times 15 plus 1219.8. That would get me my enrollment in 2015. 46.7 times 15, 700.5. So 700.5 plus 1219